Hello and welcome to Jacobs Hall. My name is Adam. I'm a design specialist here at the Jacobs Institute. And in this video, I'll be covering the safe operation of the Jacobs Hall universal laser cutters. For the most current information on our exact requirements for accessing Jacobs Hall semester to semester, sign up for our newsletter and visit our website using the links below. If you're merely looking to have a part laser cut, check out our Jacobs Project Support System, or JPS, which allows for you to submit laser cutting files for remote fabrication. If you're interested in using these laser cutters yourself, however, you're in the right place. We currently have 4 cutters available for student use. One large red laser with a 24-inch by 48-inch bed in room 120, and 3 smaller lasers with a bed size of 18 by 32 in room 110C. There are several other lasers available on campus in labs that use the Makerspace system. The Citrus Invention Lab in Satarjidai Hall and the Corey Student Workshop both have universal laser cutters that are also covered by this training. It is important to note that 2 other laser cutters on campus, the Jacobs FabLite and the Citrus Invention Lab Trotec, are not covered by this training. See the Makerspace bCourses modules on those 2 machines for details. Broadly speaking, laser cutters are used for cutting thin material in 2 dimensions. They do so by redirecting a high-powered CO2 beam using mirrors, which are attached to 2 axes of a gantry and can move around in accordance with the machine's programming. At Jacobs, we primarily cut plywood and acrylic in 1/8 inch and 1/4 inch varieties, but also stock 16th inch acrylic and see regular cutting of a few other materials like mat board and Delrin. Any laser-safe material thicker than 1/4 inch can only be engraved or rastered, not cut all the way through. If you need to cut material thicker than 1/4 inch, consider using our ShopOut or WaterJet machines, which are accessible via separate trainings on our bCourse page or through JPS. By far the most important material in this training pertains to safety, so we're going to lead with that. These are extremely high-powered lasers, and improper use will lead at very best to our retracting your laser cutter access. At worst, improper use can lead to fires, or in the event of cutting the wrong material, the generation of toxic gas. Let's address these risks one at a time. These lasers output a high-powered CO2 beam capable of vaporizing a wide variety of materials. Even under normal use, small fires will occur. Say if the beam passes over an especially oily spot in a piece of laser-safe plywood, or the buildup of matter on the lens causes the beam to slowly lose focus. For this reason, you must monitor the machine at all times while cutting. Technically speaking, all laser cuttable materials are combustible under certain conditions, and combustion can happen in an instant. We consider any fire that lasts for more than half a second a persistent fire, and the machine must be stopped and your settings or material examined by a design specialist or student supervisor if a persistent fire occurs. The most immediate way to pause the machine is to lift the lid. Lifting the lid will cause the cutting to stop and the laser head to return to 0. You won't lose your cutting progress this way, and the draft of air that enters the machine when you open the lid is often enough to blow out small fires that persist. Other ways to pause your cut include the pause button on the machine's control board and the pause button on the Universal Systems UI. In an emergency, you should also be aware of the big red button, which will cut power to the machine entirely. You will lose the laser's position on your cut, but if at any point your safety feels threatened or some element of the cutting process has gotten away from you, do not hesitate to use the emergency stop button to regain control of the situation. In the event that lifting the lid does not put out a persistent fire, turn off the exhaust, which is this switch right here for the red laser and here for the 3 smaller lasers, and grab a nearby water bottle, which must be present at every laser. Give the fire a spray. If the contents of this bottle are not enough to put out the fire, then the situation is obviously dire. Please alert a staff member as you make your way for the nearest exit. We do have fire extinguishers near each laser, but if a fire extinguisher really seems necessary after the water bottle has failed, it's likely that the situation is better suited for alerting a staff member and for your immediate and safe evacuation from the premises. Keep your risk of experiencing a fire low by monitoring your cuts closely, cutting laser-safe materials, never stacking sheets, making sure your material is clean and free of any oils, and avoiding geometries that nest too many cuts too closely together. If you suspect that your cut quality has declined because the optics may need cleaning, do not attempt to clean them yourself. Alerted design specialists will help you tune the machine to achieve the best possible cut. Another prominent danger posed by this machine comes from the cutting of improper materials. We have posted a list of banned materials on the machine itself and also have a listing on our bCourses laser cutting module. A few materials are banned because they just don't cut well. Polycarbonate of any real thickness, for example, gets sticky when cut and just leads to a mess. Some materials, however, emit extremely toxic fumes when cut. Any variety of PVC, for example, including vinyl fabrics, imitation leathers, and many rubbers, release pure chlorine gas when vaporized. These fumes will ruin the optics and corrode the metal of the machine, and more importantly, can cause tissue damage with prolonged exposure. If you found material you're interested in cutting, but aren't sure if it's laser safe, bring it to a design specialist for verification first. I should note here also that the actual laser itself poses a relatively low risk of causing you direct harm. Cutting is only able to occur once the safety lid has been closed and the glass between you and the beam is rated to protect you from the most intense UV rays. That said, we still want to be careful when closing the laser's lid, which should be done gently to avoid harm to yourself or to the embedded glass. And you'll want to avoid staring directly at the beam during cutting operations, which can be harmful for your eyes. Safety glasses and gloves are not required for use with this machine, but are of course available should you wish to wear them anyway. You should also always have an idea of where the nearest staff member is located and at least one other person within earshot. The process for using laser cutters depends on the occupancy limits of the Makerspace and how busy the semester is in any given week. So check our website or the description below for the most current updates. In general, we allow walk-ons, but highly recommend you reserve laser cutter time using our machine reservation system, also linked below. Machine reservations occur in half-hour increments and can be made up to a week in advance. Being more than 10 minutes late for your appointment will result in you losing the appointment. And if you're using the laser as a walk-on and someone has made an appointment for that slot, you must respectfully abandon the kiosk. We recommend you book more time than you need, as you can always delete an appointment, but during busy weeks in the semester, you may not be able to sneak onto a queue. Other etiquette items include job length and station cleanliness. Through the universal software, it is possible to calculate how long a job will take. Do not start a job that is calculated to run over into another person's appointment, and we also don't allow raster jobs in excess of 1 hour without prior approval. If the next appointment arrives and you're still on the machine, you must cancel your job mid-cut, which will waste time and materials. You're also responsible for leaving the kiosk in even better condition than you found it in. In times of pandemic, this means disinfecting your station before and after use. If you arrive early in the morning and the computer is off, reach behind the monitor and press the power button on the Intel NUC. Use your CalNut credentials to log in and dismiss the sign-in related pop-up if there is one. These computers erase user data every time you log out, so make sure you save all your files onto USB using the port located below each monitor. There are many ways to produce a design. You could scan a drawing and convert it to a vector file, or maybe use Fusion 360, SolidWorks, Rhino, or an online generator to produce your file. The software you'll be using at this point, in any event, is Adobe Illustrator, which we use to send vector data to the laser's native control panel. The file types you're looking to import are DXF, DWG, or SWG, or you can just open up an AI file if you've already downloaded the free Creative Cloud software to your personal computer. You're allowed to do design work on the laser cutter kiosks, but if at all possible, do the majority of this before arriving for your appointment so you don't spend all of your laser cutter time in Illustrator. For the purposes of this demonstration, we will actually design a quick file in Illustrator. We're not going to be going over all of the techniques you can use to produce laser cuttable files. We have other great videos on that. But instead, I'm just going to walk quickly through a few of the important setup parameters and line types that can get you cutting. There are 3 types of cutting defined by the laser. cut, engrave, and raster. Cutting is what it sounds like. A beam powerful enough to cut fully through your material will make incisions where specified. Engraving is similar to cutting, but at a low power setting, so it only lightly marks your stock. Rastering is a different sort of operation. The laser will rapidly jump back and forth, sort of like an inkjet printer, burning an image as it goes. This process can transfer photos, text, and details onto your material, but will of course have limitations defined by the material itself. If you're burning into wood, for example, a more powerful engraving will lead to a darker and more charred cavity, whereas engraving in transparent acrylic will lead to a matte, white textured finish, inverting the gradient of any image that's produced. Let's make a Jacob's theme name tag using all three types of cut. And we're going to do so for my dog Irma, pictured here. And I also have another asset, this Jacob's logo. This is a PNG and this is a JPEG. Definitely you want to err on the side of PNGs, JPEGs, and BMP files, bitmaps. So we're going to go ahead and open up Illustrator right here. We're going to create something new. And then I like the web preset because automatically it's going to give us in advanced options the color mode of RGB, which is essential for creating lines that the computer is going to understand as cut, raster, and engrave. So I'm going to go into point, and I like changing it to inches just because that's the default unit of the laser cutter bed, and it makes it easier to line things up sometimes. I'm right now using the red laser cutter, which has a bed size of 48 inches wide by 24 inches. Sometimes it's useful to make the dimensions here the size of the bed, and sometimes it's useful to make the dimensions here the size of the scrap material that you found or the material that you purchased. That way you know that all of your parts are going to fit on the material. I'm going to check advanced options and make sure I'm not in CMYK color mode. I'm going to be in RGB color mode. And then I'm going to hit create. So I'm going to go ahead and bring in our Jacob's logo, and this is going to be the outline of our name tag. If you're using a common file type, you can actually click and just drag this in. And we're either going to go to Object, Rasterize, and that'll take a smart object or a PNG, which may have some transparency, and it'll turn it into a bitmap of pixels. The other thing we can do here is we can go into Window, Image Trace. And this is useful for when you want to turn bitmap or rasterized images into vector files so that you can then manipulate their lines. So if I click this, and instead of choosing default, maybe I'll choose something simple, like maybe like black and white logo. And then you can change some of these values here, and that will trace it and turn it into a vector image instead of a bitmap image. So that's actually kind of handy for us. So I'm going to leave it like that. And then if we click it and do Object Expand, and I'm going to uncheck Fill just so it only expands the object, this will turn it into lines that can then be moved or manipulated. And actually, for what we want to do, I'm just going to go ahead and delete these interior bits because I want it to be Jacob's themed, and I want this to be the outside. And you can see here, it also traced the outer white square. So I'm going to delete that. So once we're down to our Jacob's logo, change this from a transparent stroke color to red, making sure that I'm at 255 for red and 0 for green and 0 for blue. This will ensure that we're actually cutting using a cutting operation. And then for the fill here, this black fill, I'm going to actually make that transparent. And the final quality we need is we need to turn this line into a much thinner line. Technically, we need this to be below 0.072 points for our dimension. I like to use 0.01 stroke. So now, if I were to hit Control P, send this to ILS, which is the Universal Laser Control System, and hit print, you can see if I click on the control system that it's giving me a red line around this object, which means that it's ready to cut it. So let's say we want to bring our image into this and then add some text. We can check out our desktop, and then we can bring in our Irma image in this case. So say I want to rasterize just the dog and not the background. You have a little mini mill with a hat here in the background. So I'm going to do the same technique that I did before with image tracing. I'm going to use Window, Image Trace. And then what I'm going to do is low fidelity photo. And then this will take a little bit of time to process. And you'll use whatever defaults work best for your operation. So if you're just doing text or something like that, you don't need to use something as sophisticated as low fidelity photo. And now if I go to Object Expand and just do the object, not the fill, you can see here I have all of the vector lines. So I can go in here and I can just start deleting any of the background that I definitely don't want to use. Okay, so this is good enough for me. So I will resize this. Right click, transform, reflect, vertical, and you can preview it if you want. Okay. I like to use hotkeys here to kind of copy my work. In Illustrator, there's the undo function isn't great. So I'm going to click this, and instead of just moving it around, I'm going to hold Alt, and that will make sure that it copies elsewhere. So if you grab all your work, you can hold Alt and copy it. So if you click two objects, and I think you need one on top, which is Control Shift right bracket, you can create a clipping mask here in Object Make, or you can use Control 7, and that will place your image inside of the top level vector file. So using this as a clipping object is going to make it more difficult to use. So that's why we copied it over here. So we can grab this back. Now we have our red line. So the last thing I want to do here is I want to add some text, and I'm going to use blue engraving for that. I'm going to use the type tool. Now, the important thing about fonts is that they don't necessarily transfer with your file. So if you send this through JPS, or if you put it on a USB and bring it over to this computer, and you've used a font that this computer does not have, then Illustrator's actually going to change your font to the default Myriad Pro or something like that. So once you're done, and we'll switch this out for blue, which is our code for engraving. Okay, and then we're going to make sure that this is 0.01 stroke. So once you're done here with your font, if you're working on your own computer, you're going to want to click anything that is a custom font and go up to Object, Expand. And what Expand does, again, is it turns it into a vector file. So that way you don't need to know the font. The computer doesn't need to have the same fonts as the computer that you process this image on. You can also, if you want to engrave the outside of this text, but say you also want to darken the whole thing, you could add a fill, and you can use grayscale because that'll help you visualize a little better. And what this will do is it'll rasterize the text, and then it'll go back in and etch or engrave around the outside of these letters, and that'll give you a really nice clean look to your text. All right, and I'm ready to go. So delete the rest of this. Make sure to save your designs frequently. So when you are finally setting up your file for cutting, go into File, Document Setup. I like to change the artboard so it is the size of the laser bed that I'm going to be working on, so 48/24. And this is after you have everything arranged and know it's going to fit onto the material that you're using. And I like to take my object and I like to move it to where I suspect I'm going to be cutting. Now, if I hit Control P and line everything up using this coordinate system, 0 and 0, and I hit Print, it's going to translate this exact artboard onto the universal software right here. And we know that everything worked because our engraved lines are blue and our cut lines are red. If we didn't have the correct settings, say, for example, we used a stroke of 1 instead of a stroke of 0.01, or the incorrect stroke, and we hit Print, you can see that when everything comes into the software, it is grayscale. It's not showing me the red line or the blue lines. And what it's doing is it's processing those thicker stroke lines as rasters. So it's going to raster all of this and not cut my file out. So make sure you have the right line type here. Okay, let's go ahead and explore the settings that are built into the Universal Laser Cutter system. This button here in the middle, this Relocate View, if you're not depending on the placement using Illustrator, you can actually place your material by clicking on these squares, moving around to the a place on the bed that's more convenient, or if you're using scrap material that has a strange geometry to it, you can find a spot on that bed and move to it. So using this relocate tool, you can relocate manually, or you can actually relocate numerically. Another useful tool is the focus view. If I click on focus view, and then I click a spot on the bed, it'll actually move the laser to that exact spot. This will help you line up your file on that material. And if you go around with a laser, you can identify whether or not you're going to be cutting on the material or cutting off the material. There are a couple of other useful items here. Duplicate view. If I move my piece into the middle here and use duplicate, I could say create a number of different items. Next, I'm going to adjust my settings. I'm going to go into settings here, and I'm going to choose from the materials database. And I'm going to look in first, Jacobs Store materials. If you purchase your material through Jacobs Hall's materials store, it will be in here as birch plywood or cast acrylic. Because I sourced this material from the Jacobs Hall scrap bin, I'm going to use birch plywood, and I'm going to make sure that I put in the correct material thickness. The way you arrive at the correct material thickness is actually to measure your material. The material from the Jacobs Hall material store and the scrap bin can actually vary considerably in thickness. So when you find your material, you're going to want to use the calipers located at this kiosk to establish the exact thickness of your material. So I measured it on my way over, and I determined that it was at 0.13. So I'm going to use the default settings plus an accurate representation of the thickness of my 1/8" material, and I'm going to hit apply and OK. The last thing I'm going to do is I'm going to do an estimate view, and this is so that I know exactly how long my job is going to take. This is really important because we use a reservation system with the laser cutters. If you only booked a half an hour and your job takes 25 minutes and you took 10 minutes to set up, you're not going to be able to complete your whole job. So if you click here and hit start, this is going to give you an accurate number for how long it's going to take. So this particular file is going to take 2 minutes and 26 seconds to complete. The final step for laser cutting, once I know that all of my digital settings are correct, is to go over here to our air compressor, turn that on, and then to our exhaust and turn that on. At this point, ready to go. I'm going to hit this green button once I've looked all around and established all my settings are correct and I have my material placed in the right place. Everything is lined up. And we can start engraving. So the order here is important. It's always going to do the rastering first, then the engraving, and then the cutting. And this is because if it did the cutting first, your part may fall down a little bit if your wood is warped, and then you would be engraving and rastering, maybe not exactly where you intended to. It would be less precise. Thanks so much for attending our Universal Laser Cutter training at Jacobs Hall. See bCourses for next steps, and I look forward to seeing you in the Makerspace.